And Eileen, if you could check that. Okay, so welcome to the Desert Blockchain monthly session on Wednesday, April the 24th, 2019. My name is Jay Carpenter, founder of Desert Blockchain, and we are at the Desert Blockchain camp at 27th Avenue in Georgia, Phoenix, Arizona. And tonight we're going to be talking about decentralized voting and zero-knowledge proofs. And we're actually going to be doing a decentralized voting demonstration using, I don't know if this would actually qualify as a zero-knowledge proof, but we'll see. We'll see how this comes together. So we're just kind of finishing up, going around the room, introducing ourselves, and if we could go ahead and continue that. And Randy, why don't you tell us what you're interested in?
Yeah, I'll give you a quick background. My name's Randy Graham. I'm a consultant in the healthcare industry, primarily accounting, finance, and reimbursement realm. Been doing that for quite a few years. And about 2 years ago, I just kind of woke up and said, I need to figure out what else is out there for me. I still enjoy the work I do, but so I really started to look into what new things were happening. Blockchain and Bitcoin kind of rose to the surface. So the last couple of years, I've really been focused on learning everything I can. And what I'm really trying to do is, without spending a lot of money, I want to try to learn as much as I can for a amount of time to see what kind of new career path that will take me into. I don't know if I really want to go back to school and pay a lot of money for something that's not proven yet, really. I just want to learn and figure out where that's going to lead me.
And Randy's been participating in our Saturday workshops at 2 o'clock. If you're not familiar with this, at 2 o'clock we generally have some sort of technical workshop. We're focusing on Raspberry Pis, which are little computers, simple board computers. And we'll probably continue to do that. This is a Raspberry Pi. It's $35 at Fry's Electronics, or you can get them online. Another $7 for an SD card. Very powerful. You can do a lot of stuff on this. I'm building a telephony platform on this using something called FreeSwitch. And so this is like a full-blown telephone company on this, as well as you can do video, like Zoom and everything else. Anyway, so I would highly encourage you to come by on a Saturday, even if you don't know how to code or do anything else. It's really a great way to learn. It's a great way to get some open vistas on some cool projects, and we're happy to help you get started. So, Julian.
All right, first, my name is Julian. My day job is a programmer. I've got a side project using zero-knowledge proofs to achieve like a private version of all tokens on the Ethereum network. That's kind of on hold after talking to Daniel, while we also pursue actually a zero-knowledge system.
Cool. Niles.
Maybe skip it.
No, Randy.
Oh, you did. Okay. I didn't think you said that. I'm Niles. Hi, Devin. How are you doing? This is with
So I met Niles going on a year ago at the Nexus conference, and I do this thing which is similar to what we're going to do tonight, where I build a blockchain out of newspapers, and I asked for a couple volunteers, and Niles stood right up and volunteered, and then another fellow, AJ Gilman, stood up and he volunteered, and it was, I didn't know it at the time, but I was meeting two of the most incredible people I've ever met, who are all Paul Watkins will be coming in from Washington, D.C., and Paul was here with the Attorney General's office and basically was the architect of the sandbox, the FinTech sandbox. He's now with the Consumer Financial Protection Board, and he's architecting sandboxes on a national and actually global scale. So I could go on, but what we're going to be talking about tonight is a precursor to that presentation. Yes. Oh. Well, that's because you're a problem. No, they don't be a problem because I'll connect my screen. Sorry about this. Yeah, I don't know what's going on. Now that they're okay, so the image is of Where's Waldo puzzle. So we're actually you will actually get a Where's Waldo puzzle in a few minutes. But a zero-knowledge proof, basically the way I get my head around what a zero-knowledge proof is, it's like finding Waldo within this maze of people and whatever, and then proving that I found where Waldo's at by simply saying maybe the color of the shirt that Waldo's wearing, or maybe Waldo's got a number on him or a certain type of glasses. I could disclose that would prove it, or there'd be a high probability that I knew where Waldo was at without actually disclosing Waldo's location. So that's about the simplest way that I can explain a zero-knowledge proof. So,
But someone has to verify that you stated the correct truth.
Yeah, there has to be a verification process, and Julian's better equipped to speak all that than I am, but we'll see how this test run goes. So our process now for voting usually is some sort of centralized process. So we register with some sort of centralized entity in order to be able to vote. We then cast our ballot that is then collected by some sort of centralized entity, and we're trusting them to accurately count the votes, and so that there's a whole bunch of trust in others, when we're voting now. And that leads to a whole bunch of problems, a whole bunch of distrust that I don't think we need to go into just yet. But obviously, if there was a way to do it in a decentralized manner, where we could all verify and validate and audit what happens, that becomes very appealing. But the other appealing part of it is using zero-knowledge proofs is, what if we could do that without disclosing our identity? That could be really, really powerful. So that's basically what we're talking about. So the advantages of decentralized voting are a known way to conduct voting. systems are already in place. Most understand how it works, and there is a certain degree of trust. So here's a Wikipedia page on voting, and I'll just kind of focus in on this particular person. So this is a voting process somewhere, and the fellow's holding up his finger, his index finger, which shows he's got some purple ink on his index finger, which means that he basically marked himself as he has voted, and that indicates that he is a voter. So that whole process just speaks to somebody has disclosed their identity. Now, in an adversarial situation, that could be actually be life-threatening. So, that's a problem. First of all, before we go on, any questions, any comments? This is kind of a open conversation.
And the picture was after the first active.
Is that what it was?
So I had an experience
Okay.
with my mother
Uh-huh.
and the board with regard to this. She was removed from the voting poll because she had registered to vote before electronic records. Didn't re-register and she wasn't able to take altogether. So then, now they talk about this with Adrian Fontes directly. You have a distrust. Because she was just, she had voted every single, she, diehard about voting. And so now she and a few others who were also have huge of the system, whether or not their vote was accurately counted. But at the same time, they don't want to disclose how they voted in order to get trust that their vote was counted and come back.
And that's in the United States.
And that's here.
In Arizona.
That's here. That
Right.
was not even a year ago.
Yeah. We're not talking about Afghanistan. We're talking about Arizona. The other state that starts with an A. So, I think, there are numerous stories like that. And so I was at ASU Law last Wednesday, and I spoke for the blockchain lunch with David Schweikert was there, who's our congressman from Arizona, who is co-chair of the Congressional Blockchain Caucus. And he is focusing on this Real ID Act that actually bubbled up in 2005, I believe it was. And it's basically a way to do sort of like nationalized identity. And Congress, who can't force apparently the states to do anything, but they can start to restrict people that don't have this real ID. Congress is moving to require that you have to have registered your driver's license with this Real ID Act in order to use your driver's license as a way to get on an airplane. And that might be happening as soon as 2020. And Congressman Schweikert is talking about using this initiative or this shift to start to bolster the back office operations of the Maricopa County Registrar's Office and all that stuff. Now, I think he's a bit optimistic, but certainly there's an appetite to start to bring these systems together, so there is some sort of harmony between these disparate systems where, just like your mother, if you get dropped from one, it can create all kinds of havoc throughout your life and what you can. So, what is decentralized voting? I'll just take a stab at this, and anybody's welcome to chime in on this, but decentralized voting, in my view, is a way for us to both vote as well as verify that all the votes are legitimate and what is the tally, without relying on somebody else to do that for us. Which, if you think about it, that's pretty powerful. So that's what we're going to do. So let's talk about 3 points about voting. Number 1 is trust. You have to have some sort of trust in the system, or else things can go horribly wrong really quick, including like civil wars and so forth. Number 2 is identity is a key piece to this. Can't be having the votes sort of polluted with, people creating identities in order to just vote.
Oh, you mean that unlike Chicago,
Vote early, vote often, that's right. So now the trick is, how do you do this voting with some sort of trusted identity without actually disclosing who's behind that identity? And that's what we're going to be playing around with tonight. And then the last thing is adoption. And I think that's where we really have an opportunity set here in this playing around with zero-knowledge proofs and so forth, is how do you get people to trust it? How do you get them to use it with some sort of trust that their identity is going to be treated in a responsible manner? And then how do they actually do it? How do you get somebody who's not tech savvy to use this type of system? And that's a really powerful opportunity set that I think we have among the Desert Blockchain community, and building some things and starting to experiment in this realm. And it's applicable to the legacy systems like regular, voting in elections, but it's also applicable to voting in these decentralized constructs like blockchain. As we move from centralized authorities, we need a way for people to weigh in on certain issues and so forth. And that's been a big holdback in Bitcoin, basically. Don't have, the good news is you don't have a central authority. The bad news is you don't have a central authority, so nothing gets decided. So here's a little video of zero-knowledge proofs. Here's the image again of Where's Waldo, and I actually have went out and bought the Where's Waldo book. If you haven't seen, if you're not familiar with Where's Waldo, this is Where's Waldo in Hollywood, and it's got all kinds of puzzles where you can sit there and try to find out where Waldo is at. But here is a Where's Waldo puzzle. And we might need some flashlights for this. But this is a piece out of that book of Where's Waldo. And Waldo might be in here. I still haven't figured out where it's at. But this is going to be your ballot. Okay? So on the front is this puzzle. And everybody's going to get one of these, and on the back is your actual ballot. Okay? But in order to vote, and you might think of this as like your public key, so that anybody can see this. Your public key is, in this particular instance, is all the same. Hey Scott, just in time. So another zero-knowledge proof expert. We're starting the exercise. So I'll just quickly introduce you, Scott. Scott is an expert in Monero and an expert in privacy. So what we're doing is we've just handed out the ballot, okay? So within this puzzle, are certain words and certain numbers that have been added to the puzzle. And now what we're going to do is we're going to pass out the private keys, which are within this. You're actually getting an extra one. Within this envelope, there is a private key that is unique, which is basically a white page that says, I'll show you an image in a moment. It's a white page that says top of private key, and that will lay that on top of this ballot, and that's going to show you a word and a number, which you'll write on the back of your ballot. So who would like to vote? Let's see, so we've got 4 out. We need 1 here. All right. Now I was going to do something to kind of make it a little more random, which was I was going to make you give up your vote to the person to your right or left, but I'm going to skip that part. So here's how you vote, and we're going to do this in the next 60 seconds, basically. So I'm going to start a timer. So you should take out that white piece of paper that says private key, and lay that on the top of your puzzle, and that should disclose a color and a number. And you'll want to write that color here and the number over here, and then I'll show you what to do next. Okay, so does everybody understand that? Take your private key, put it on the puzzle, and that should zero you into a word, which is a color, and a number. Okay, and you've got 15 more seconds to do that. And then write it on the back of your ballot. Okay, time's up. So put your take everything out of your white envelope and put your ballot in the white envelope.
Putting down the color and the number. That's it.
Yeah, actually, what you should do now with the color is count the number of letters in the color and put the number of letters over on that line, and then total it up. Don't tell anybody what the total is. And take your ballot and then put just the ballot.
Where it says vote,
Oh, I'm sorry. So vote, you should do, you either put in North team or South team. That's your vote. North team or South team. Sorry. And assume that there's no significance to either team. Just vote on one of them. Okay, so just your completed ballot in the white envelope, and not the key. Keep the key. Key is your private key. Also, sorry. Okay, does anybody have any questions before we turn these in? Okay, go ahead. Do this, 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 this. Yes. And Daniel, will you mix these up? Just mix them up. However, okay, good. So grab the first one and take the ballot out, please. Okay, cool. So we have ballot number 1, which has a color of white, number 5, which is correct, and they successfully found the number 25, and that adds to 30, and they're voting for the North team. Okay, second one. And so this is, and anybody's welcome to come up and see this. You don't have to, but this is, the color's red, 3 letters, 27, and that also equals 30. Okay. Next one. And so this is, the color is green, and there's 5 letters in green plus 25, and that's 30 also. So this is our 4th vote. Oh, and they voted for South King, so we got 2 South King votes, and this is a North King vote. If it's a valid vote, yellow, 6 letters plus 24 equals 30, so North King. And the last one, the tiebreaker, is so this is blue, which is 4 letters plus 26 is 30, North. So we've got 3 North votes, 2 South votes. Now, can you see what just happened? Isn't that amazing? I assert, at least I have a high degree of confidence that each one of these is a valid vote because each person was able to apply a private key to the puzzle and they came up with what looks like valid answers. They did not know that's 30-some total before they voted. So I have a high degree of confidence that each one of these pieces of paper came from somebody who applied the private key to the public key, if you will, and discovered where those 2 bits of information were in the puzzle without disclosing to anybody else where those 2 pieces of information are in the puzzle. And we mixed up the votes, and I would challenge anybody, unless you know the handwriting of the person, you cannot determine whose vote is whose, right? That these are valid votes. They came from 5 people among us, and that those 5 people unlocked the puzzle. They voted without coercion. We don't know who they are. And here's the other part about it that's really, really cool, is each one of those people that voted, because this is public and transparent, can be assured that their vote is in the count, right? Now, when I put my ballot in a election here in the county or whatever, or state or presidential election, I have no idea if that thing went into the final count. So the winner of the election in this case is North Team. Would anybody dispute that?
So your physical description is fine because it's valid because we all watched it.
Mhm.
But in real life, you don't get to watch the count.
Right.
So when you think about trust, what is the mechanism that allows an undisclosed location and an undisclosed method that tallies the votes that it really did count? I mean, I still really do. Only reason I know it got counted was I see the page, I know what my answer was, I know because I witnessed the count that it's correct. But if I didn't witness it,
Mhm.
and you went over in the corner and did it,
Mhm.
how do I know that you did it right?
So that's where Julian's going to come in and talk about the sophisticated math that goes into how does this work when it's actually online in a blockchain construct. How do we have the confidence that the math is doing what we just experienced as a small group, and but basically fulfilling the same goals? Does that make sense?
Yeah.
Because we're cutting through a bunch of the complexity because we are all in an open environment, transparent environment, and you know, we all saw what happened. It's similar to like an open area auction where people are shouting out prices and whatever, and out there you're disclosing your identity, but you're signaling prices. But this is even cooler because you really don't know whose vote came from whom in this particular construct. But because it's a small group, in a transparent situation, I would say, and somebody correct me if I'm wrong, Scott, Julian, or whomever, you know, where could this process be? And you don't have to answer that right now. So that's basically a demonstration of a decentralized vote where the specific identities of the voters were not disclosed, and we have a high degree of confidence that these 5 voters actually solved the puzzle using that private key without disclosing the specific identities of the voters. Right?
So what's the advantage in this case of doing the public-private key as opposed to writing down north or south on a sheet that doesn't have a name on it, fold it up, turn it in, and it's a big count of
You
votes?
tell me, where could the second process be defeated? Or where could you corrupt that process? If we just passed out 5 pieces of paper and wrote down north or south, pass those in, why would that be less trustworthy than this?
Everybody watched what was going on, and you would see by inspection that it was still okay.
Well, I assert that there's a greater opportunity to corrupt that process I hand it over to Daniel. He could have changed the votes. I could have changed the votes. I could have slipped, my votes in there.
I guess my point is, you could substitute a ballot with the way we did this, just the way you could substitute a ballot in any computer system. It's a sleight of hand that gets it done. And the sleight of hand could have been done here where the same end result, but maybe you say, well, the vote is not valid because the numbers don't total 30.
Well, here's what I think overrides that.
Or you could have a ballot which knew what the numbers were supposed to be, and all you did was change the value of whatever the vote cast was, north or south.
Well,
the issue is we tampered with the paper ballot.
And this is great conversation. Perfect. I want somebody to challenge this, because I don't know all the answers myself, but I assert that with the just simple north or south on a piece of paper, you have no way to audit that your vote is on the board. Nobody in this room, none of the 5 people are saying, wait a second, my vote isn't up there. What happened to my vote? With the north and the south on a piece of paper, you really don't have a way to determine if your vote is on the board, right?
In this circumstance, I can tell, I know what my code
You
is
know,
like,
you know what your color was, you know what your number was,
so I can say yes.
you can say yes. Nobody is saying, hey, wait a second, my vote's not up there. With the simple north or south on a piece of paper, you don't have a way to determine is your vote on the board.
So that's what I wanted to bring out, that just with the simple word, a single point of reference, they're much harder to prove that they're valid at the end. Here you've got 3 points of reference which have to be corroborated. So that's a much higher level of
Trust.
veracity, trust that you can prove without being argumentative.
Yeah,
I mean, you know that's.
No, this is perfect.
But, playing it fancy for you. But the point is, I've done these kinds of exercises and I had people walk out of the room and say, you didn't prove anything. Because they see, in their mind, they see a way to corrupt the paper ballot because they don't like paper ballots because historically they've been corrupted so many times. And so that's why.
Yeah, that's perfect. It's perfect, sir.
Well, so
Thank
just as
you.
I was watching
Andrew.
this unfold and hearing your, devil's advocate
Right.
response, the idea that the votes could have been corrupted just in the handling and passing them through, wouldn't that question kind of be counteracted by the idea if this was actually happening on the blockchain, you have the immutability of actors, so that wouldn't really be a concern unless you have a bad actor coming in and trying to disrupt the record. Am I understanding that correctly? Like, didn't that concern that it could be manipulated?
Well, what
along the
happens
way?
if you get a corrupted chain and then all of a sudden you say which ones are right and which
But
ones
then
are
you
wrong?
have
And now all
everyone
of a
coming in
sudden,
and voting.
you may not
and then
necessarily be able to untangle.
Well,
You may corrupt the entire voting process at that point.
Here's
For
another
some
dimension.
people, that's all they want.
Here's another dimension of that, is you might not be able to vote on a blockchain, even with a public-private key such that it's as anonymous as this was. So you might be able to cast your vote on the blockchain, but there could be ways to determine that that was Sarah's vote, even though it's on the blockchain. And you can be putting your life in danger because you disclose your identity.
If it's a blind identity and only you have the key, then it's possible to have a true blind vote. But if it's a published identity key, the issue that you brought up is certainly a concern.
Yep.
Another concern is, what's prompting my comment is, if you're guessing private key, you can actually corrupt the process. I don't know if some of you read about this, but a couple of days ago, there was a news item that somebody had guessed the private keys of various individuals installed and say 45,000 Ethereum.
Oh, there's some guys that are doing some brute force hacks on keys, and they're just submitting those as brute force attack against the chain, and when they hit a key, which just give it by chance if you use a brute force, eventually you're going to find something. And that's essentially what they've done, right? An algorithm that does a brute force attack. Using a key chip.
With respect to that, though, it's with each private keys, like
Yeah.
one, like,
Yeah. But the point being is that's how they do it. It's not a blind guess.
Yeah. Yeah,
They're using workforce algorithm.
well, Scott's bringing up a great point, is if you don't take care to have enough entropy in creating your private keys, your key structure, then it can be brute force and defeated. So Jason Horton just joined us. Jason's the co-organizer of Desert Blockchain, and he was the featured Desert Blockchain member last week because he's with a project called Nori, which is doing a carbon removal exchange. And there was an article in the Fast Company about Nori, and in the most recent ASU Thrive magazine, there's an article about Nori. And Jason's also mentioned in the Greater Phoenix Economic Council brochure that they pass out to everybody about his work with CryptoPal, which is a cryptocurrency wallet exchange, so not an exchange.
I wanted to bring up that this is that another thing that could be just dissuaded is that the centralized entity that the neighbors who can vote, that could really be corrupt. Like, for instance, like your top voter that you're saying voter perjury and stuff like that. So that's another that could be like, there are some voting systems that could start like Ethereum where you just generate a whole bunch of tokens and just send those to the wallet you want to vote for. And that's how voting works, but it's, kind of take on get the private keys or run this, but as long as the central entity chooses can vote, they're still have to sway.
Yeah, there's vulnerabilities in many of the constructs for voting, for doing things on the blockchains, even though the blockchain's immutable and you're using public-private key constructs and so forth. There are vulnerabilities, but this realm of zero-knowledge proofs, I think, opens up a whole new vista, and you guys can correct me if I'm wrong, for adding both the high degree of trust, transparency, and yet keeping the specific identity of the voters private. So great questions, great.
I like your example of your little games.
The game?
Yes, it's great.
Oh, okay, this.
Yeah.
Good, thank you. Thank you. Does that open up something in the zero-knowledge proofs and decentralized voting that you hadn't seen before?
Not really, but it's a nice way to begin to open up the discussion about what kind of work a zero-knowledge proof could do in these cases to help protect both identity and veracity.
So this is just a brief description of what we just went through. That's pretty much it. There's more to this. There's some articles and things like that on zero-knowledge proofs and so forth. So that's basically the demonstration, and hopefully, do you see any? There's obviously, because this is paper and because whatever, there's faults to this. But is there anything you see that's wrong with this, Julian?
I could probably try to explain how you would actually take this concept and actually go about actually implementing it.
Yeah, I would like you to do that. Scott, anything you see, any comments about?
Well, I think comment kind of on the recent event, someone who follows photography. There's a really good photographer by the name of Sarah Jamie Lewis. She and I forget some of the other photographers, basically some European country, I want to say it's more than a base, that basically was going to, within this most recent election cycle, have a open source like zero-knowledge proof voting system, and they basically audited it and kind of blasted it to smithereens. And like the company itself, like tried to discredit the cryptographers, and there was this whole kind of like arguably nasty feud between them. So that's just kind of an example of like, even though you have like something that's transparent code-wise, and there are people who are currently trying to do it, there are, because of the complexity of how complex the systems are, there's just so many issues that there's arguably a lot of cause for concern that if you were to try and push a like voting kind of zero-knowledge proof system, there would be a lot of skepticism in the cryptographer community, based on recent events and so forth, about how safe and good of an idea that would be. So yeah, I would like look up Sarah J. Lewis and read her audit. If you're interested in hearing.
So do you think this is going to be possible someday?
I mean, potentially. I honestly, like, a lot of the people within kind of this space, so like DEF CON, for example, there's a guy called, sorry, I'm phrasing this, I'm totally spacing on his name, but he leads the DEF CON voting village, where they basically bring in machines and they basically hack them and try to manipulate the votes. He's in favor of basically always having a paper trail at bare minimum. I forget what the specifics are. There's like 3 points. Like you can have a digital, open source digital voting system, but you also really need to have a basically paper trail where you don't have like pain, tabs or whatever. Like it's the punching method doesn't leave room for error.
Cool. Well, Julian, I'll turn it over to you to elaborate further on this.
I will try to just make parallels to this. Okay, so I guess implicit at the beginning was at this phase we had sort of a registration process where we had a pool of keys that were already generated. And this is going to be the weak point of any actual decentralized voting system. And if you're actually trying to realize this, it's the hardest problem to solve, but I guess you tie into that real ID stuff, I guess, that we're talking about. If you had a system theoretically where you had all these real IDs, which are vetted identities, and you can have them all generate private keys that they hold secretly, and then use those to generate public keys that they can use. And then you say, hey, voter registration process, everyone give us your public keys, and then just over a span of 2 weeks or something, everyone give you public keys. Then what you do is you create a Merkle tree of those. Actually, let's have them not even give you the public keys. They give you a hash of the public key. So we don't even know exactly who's registered. So now, and of course they use the blinding factor, so it's a hash with some other random number. So we can't even just guess, like, oh, Sarah vote. Let's take her public key. Oh, there's that. So now it's a random number with it, and we can guess. So now we have all these blinded hashes that we use to create a Merkle tree. And then this is going to be actually used for the voting process later on. So that's the registration process. When you cast your vote, you know your private key. You're able to identify your public key, which is similar to finding your number in color. And you're able to cast your vote, which instead of actually going through the process of doing like all the math and stuff there, what you're going to do is provide a valid Merkle path to the root hash, which is publicly disputed. I skipped that probably. So you take all your hashes from the tree and get a root hash, and you have that, that's public. And so in your zero-knowledge proof, you're providing all the intermediate hashes, also with your private information, proving that you know the private key for the public key, and the blinding factor produce the hash that's public. And then now you provide, okay, this one, this hash with this other one, and this one, which are publicly available. It's just the unique nodes contents you have to figure out in the location, and you're able to produce a root hash. Doing that inside your zero-knowledge proof is basically equivalent to calculating a total. And with that, we could find another random element that we include that's signed with the same private key that was used to register. You can do that to sign an arbitrary ballot, which could be, in our case, the word red team or blue teams.
or it could be a JSON array of all registered, I don't know, anything, whatever you're voting on. And so then you have this public vote, and you generate a zero-knowledge proof where you haven't revealed yourself. And so now you just have like a networking problem, broadcasting that to the network, use onion routing to on Tor. You can get some level of privacy depending on who's running the nodes. And so with that, you can get your privacy. Now we have a public vote, and those can be tallied now by everyone. I guess that's one thing that should also be made apparent about decentralized voting. Similar to how Bitcoin's don't trust, verify, the same kind of thing. There's no one person counting all the votes and then telling us the results. We have all the results public, and we are able to count them ourselves. If that makes sense.
Well, I think that's a huge difference between centralized voting and decentralized voting. And yeah, everybody can verify, audit what happened. Anybody has the slightest doubt, they can do, which you can't do with running centralized systems.
I guess maybe I need to make a note, just explain a little bit more about in the zero-knowledge proof what that means. With the zero-knowledge proof, you can take an arbitrary computer program and boil it down to a verifiable proof that the program is executed correctly without revealing what the inputs were. So it's a way of proving properties of information without revealing what the information is. You have to make specific programs for what you want to prove. In our case, we make a specific program that does the computation of the public key from the private key, and also the computation of a node in the Merkle tree, and also the computation of the root hash, and then also the computation of like the verification of the signature of the ballot as well, which you would probably just use the hash of the ballot. That makes sense. You could take arbitrary programs, run them through these transformations. The math involved in taking an arbitrary program is very complicated, and it's probably a 90-minute presentation. That's about how long it took me to do it last time. But yeah, it's really interesting math and very, very shaky, very unreliable. Initial version of Zcash turned out to be broken based on the way they do the grouping key ceremony. So yeah, very experimental, very dangerous stuff. That's cool.
Yeah, but we are moving in a direction to have this become reality, which I think opens up whole new realms for us as a society in terms of governance, trust, all of those.
So how old is, in the computational world, how old is the zero-knowledge proof?
Well, it goes back to the late 80s, but the latest forms that are actually starting to see use in blockchain applications, these are ZK snarks. Those really came about in 2013.
I was going to say it's only been 3 or 4 years.
For the ZK snarks that work in blockchain context, before that they were probabilistic and interactive.
Right.
So it would have to be me back and forth with you. I'd ask you about your ballot 100,000 times. So I'm convinced that it's a valid ballot. But now, ZK snarks, it goes through this pairing transformation that makes it easy to create system proofs.
And that little video that I have in the presentation talks about the difference between interactive and ZK snarks, where you have one set transaction.
Any other questions?
Probably. The other thing I'd like to say about Julian, if you're interested in this, on February 2nd, we did a blockathon at Local Motors, and Julian did a great presentation on
using a tool you can use, using a programming language that kind of looks like Python to a little bit. You can write your arbitrary programs and generate all the code for you to actually do this. And it's a tool called, it's a pun on the philosopher, so Socrates. It's Zocrates, with ZK and an S and C. But because of the Billick background, I call it Zocrates. And it's just a nice tool. You can use it to generate proofs, generate programs from high-level stuff. And you can actually export that into a Solidity smart contract that you can use with your network. So, of course, I think there's some issues with it, but experimental, fun stuff to play with. Actually, either do that.
So if we had stronger identity that could be the genesis for the public-private partnership, that would go a long way towards making this solid and sound.
Yeah, that's the first problem solved.
Usable. Cool.
So what's the biggest problem with the original identity?
Well, we have to have some system where we determine whether someone's an eligible voter or not. Just as Niles pointed out, you can have entities using all the rest of the system that's actually really sound, but they could be arbitrarily deciding who voters are, which kind of force the whole system.
So let's take the voting piece off and just talk about the zero knowledge piece.
Okay.
Because there are a lot of other applications for zero knowledge other than voting, if you will. Let's just think about the zero knowledge. From that point of view, and from the cryptographer's point of view, what are the weakest points in the zero knowledge proofs right now?
Specific proving systems, or
The ones that have been put forward so far, most of them are proof of concept type situations that I've seen so far.
they're very academic. Not
Yeah,
really
they're
soundsy.
somewhat esoteric in a lot of cases, the few that I've seen. They well, that's a really great idea, but let's bring it down to everyday life and see if we can do something. In my specific case, I'm looking to potentially use zero knowledge proofs to prove that somebody has something in a box without telling you what's in the box. But we're going to exchange currency values based on what's in the box. And we'll set up a set of rules that say when, if, and how that transaction will happen. But you're never going to enter that transaction unless you know the value is actually in the box, right? Otherwise, I've created a fraud.
Right. I think you might want to look at zero knowledge contingent service payments. That sounds very similar use case.
Yeah, and we looked at those, but what I was hoping to talk about tonight was what are the current weaknesses in the applications of zero knowledge proofs. Now, we've talked about voting, and in voting, the specific issue is the issuance of the original identity. So in the case I just mentioned, we have to both agree that we are who we are, so we still have the identity issue to deal with, but assuming we'll pass over that for now, just focus on the zero knowledge proof side. What are the weaknesses just with the proof mechanisms that we currently have to work with?
It's probably the same weakness as in every breakthrough cryptography. Eventually we'll find something we didn't know before, and it can break the system.
Okay.
And so you have to try to make your system resilient to that, maybe a little bit more modular where you can actually do drop-in replacements of different parts of it. But it's very complicated because having these programs is going to be very specific to your system.
Well, it seems like the logic is almost like a cascading logic, and if you change one piece and the cascading logic, the derivations later on, it makes it very difficult to make it modular, I guess is the point.
Yeah, it is.
Am I looking at it correctly, or did I miss something?
No, you have to make the voting verification part probably separate from your actual Merkle tree.
Okay.
So you don't want it to be specifically tailored to like a specialized algorithm that only works very well in this particular field.
Right.
Which is looking like the way things are headed right now, just to get more efficiency with Merkle trees right now. Cool. Any
I have just a general question on the Merkle tree concept. I just need to begin to work on understanding better, I think. So I was just wondering if you guys had any recommendations in terms of resources.
are you familiar with the hash function?
As much as I've studied on Coursera.
Okay, so collision resistant, right? You don't know the output, or you don't know the input from the output. So you can use the hash function and take the hash function. Let's say we had, I guess we'll go through this example again. So let's just do a simple Merkle tree. Your ballot, it's maybe just your name, so the hash of your name, and then we could do Niles's. So we have the hash of this name. So now what we can do is take both of your hashes, concatenate them together and run it through the same hash function again, now we have one hash. And now we can verify that it was both of you by taking those in the same order and producing the same hash. So now we've taken data from 2, condensed it to 1. And then if Niles wanted to prove that he knew his, he could use his name and the hash of yours and produce that same hash. You likewise can do the same without knowing that it was maybe Niles or some other secret that he used. And you can use your secret, his public, and produce the same thing. Now, because it's a tree-like structure, we can do that several times over. And it's kind of like binary kind of structure. We can do that with everyone in the room, as long as it's the power of 2 with dummy data in there. And we can all agree with this dummy data to 0 or something. And then we can now use that to create what is called a cryptographic accumulator, where we can all prove set membership by using that verbal structure to produce the root hash, using only our private knowledge and everyone's public information, which the hash is.
Okay.
Does that sort of make sense?
That's helpful. It's
Yeah.
an involvement on what I know, so thanks.
Cool. All right. Thanks, Julie.
Nice work.
Well, first of all, thanks for being here and contributing to the conversation. Great conversation. And our gathering constitutes kind of a nucleus of possibly creating something cool, that might make a difference. And that's the whole intent of this thing. So, I think that's about all I have tonight, but I would mention that this Saturday we're going to have our next Arizona Blockathon from 11 a.m. to 8 p.m. here. And, basically if you've got some level of coding skill, you've been say a year, you've been coding for a year, you're welcome to attend. And the idea is to, collaborate, learn, and hopefully start to come up with some ideas on projects that might be continued forward. So there's a meetup page for that. We will have another one in July, and we're talking with one of the local, actually not local, but global cloud providers about they want to get involved in this, and it's likely that we'll be reaching out to some of the public administration entities in the state, county, municipal, to get involved in the one in July, which will be the last Saturday in July. We're also talking with the same company about our next monthly session in May, having a theme around veterans. So we don't quite know what that's going to be, but veterans and blockchains, some of their projects and whatever. So that's kind of what's on the table. I have started on Thursdays sort of sending out a digest of some of the events that are coming up. And I started a program called the Citizen Passport, where you can nominate events that are coming up, like the Gets. There's one nomination so far. And second nomination, if Get says, yeah, we'll give you 2 free passes and 3 50% discount passes, then the 2 people that nominated the event will get 2 free passes to Gets, which is worth like $200. You do have to be a citizen to participate in that, $10 a month. We're going to be rolling out more citizen projects and benefits and stuff like that. But that's the Citizen Passport project or opportunity. And there's some other events in there. But basically the shift is going to the community now to come up with events and ideas and so forth. And, we'll have ways to submit information, and not necessarily vote right off the bat, but at least get solicited input. So unless there's any other questions or comments or whatever, we'll wrap it up for tonight. And thank you for coming. Yeah. So enjoy this pizza and continue to mingle. We would like to be out of here by 9. So, all right. Thanks. Thank you, Jay.
They must try to keep that.
There you go. You're welcome.
I am so happy that you guys understood that. People are filling the ballots. It's amazing.
Well, yeah. So,
And I literally went straight to the secretary's office. This is what happened to me.
first off,
And
These are monthly. Okay.
Oh, wow.
And the next one is May 22nd. And then the Boscons are Thursday. Okay. So they one Saturday. Those are, like the first half of it is like before lunchtime is college talks. And some people come just for those talks and say, hey, we're going to spend most of the day recording services to this. And the second half is when people can actually work on projects that somebody brought or came up with. So the person that they things was real estate.
I don't know. I don't know.
Promise that they will take more Yes, exactly.
No,
Send somebody from the office.
I literally just came up with this.
Really? Okay. All right, so I'll try to be a little bit, isn't it? So I'll take it their way and say, hey, listen, we had this issue, we know it exists. I have a bunch of public record conversations with them with regard to it. So,
So, good.
Yeah.
Yeah.
And besides, it's so fun to just kind of just shadow and get my own the application on my own, something like that.
The number of ones that I've done is still not able to so Jay's done some introductory kind of coding things, maybe go to next doing that again, and then Thursday the focus doing video. I was just doing live videos to Twitter and Facebook, so you can actually listen because I'm trying to maneuver so that I can get quick pieces down so that you can over there. And so I get better actually than the live stream on YouTube. Sometimes that's okay. But you actually cannot see this stuff. So so I can actually listen to what I'm doing.
Yep. That